5.4, we're going to talk about sum and difference formulas. So these formulas will be given to you. You don't have to memorize. You just have to know what to do with them. So there's kind of two parts to the formula, depending on what type of question we're doing. We're either given one half, we have to use the other, or vice versa. So we have sine, where we're adding two things together. If that's the case, then we use this half of the formula. If it's sine and we're subtracting two things together, then we use this half of the formula. And so on. Same thing, cosine, we have an adding and subtracting one. Tangent, we have an adding and subtracting one. So we use the sum and difference formulas when we're given an angle that's not on the unit circle. So looking at example 1, we have cosine of 75 degrees. Is 75 degrees on the unit circle? No. But we can make up 75 degrees of two numbers that are on the unit circle. What are two numbers that either add or subtract to 75 that are on the unit circle?
45 and 30.
Perfect. 45 plus 30 would be 75. So cosine of 75 is going to be the same as saying cosine of 45 plus 30. So we always want to either add or subtract using two numbers that are on the unit circle. So since we're going to use cosine and we're adding the two numbers together, we're using this formula here, so the right side of it is what we're using. So we have cosine. Here it uses u and v. The first number is going to be your u. The second one's your v. So we can just plug those in. Cosine of 45 times cosine of 30 minus sine of u, which is sine of 45, times sine of 30. From here, we're just going to look at our unit circle to find each one of these. Cosine tells us we look at what on the unit circle? The x. So I'm going to go to 45 degrees and look at my x value. What's my x at 45 degrees? What's the x? Square root 2 over 2. So this would be square root 2 over 2. Same thing with cosine of 30. Cosine tells us we look at the x value, so we're going to go to 30 degrees. What's our x value at 30 degrees? Square root 3 over 2. Then minus, sine tells us we look at what? The y. So I'm going to go to 45 degrees. What's my y value at 45 degrees? Square root 2 over 2. And then same thing, we're finding the sine of 30 now. So we're going to go to 30 degrees. What's our y value at 30 degrees? 1/2. Now we want to multiply these and then subtract. So when we multiply with fractions, we're going to multiply straight across. What's square root 2 times square root 3? Square root 6, perfect, over 4. Minus square root 2 times 1 would be square root 2 over 4. And we can subtract these together because we have a common denominator. That would be square root 6 minus square root 2 over 4. So this would be our answer. So we're going to do the same thing for b. Pi over 12 is not on the unit circle. So how could I either add two things together or subtract two things to get us pi over 12? It's a little bit harder with radians. If you want to convert it to degrees, you can convert it and just do the math that way. And when I convert it to degrees, what do we multiply by? 180 over pi. The pi's cancel. What goes into both 12 and 180? How many times? Start with something smaller if you don't know. 6 goes into both of them. 6 goes into 12 2 times, and 6 goes into 180 30 times. And then 2 goes into 30 how many times? 15. So this is the sine of 15 degrees. What two numbers on our unit circle either add or subtract to 15 degrees?
40 times 30.
Awesome. So this would be the sine, because it sines our trig function that we're finding, of 45 minus 30. 45 minus 30 would be 15. So sine of 15, 15 is not on the unit circle. We had to find two numbers that were on the unit circle. Now we're going to use our formula. So we're using the formula of sine when we're subtracting. So that would be the second one here. So sine of u minus v, we're using this part of the formula. So the first number is going to be our u. The second one's going to be v, and we're just going to plug them in. So sine of u would be sine of 45 times cosine of v, so cosine of 30, minus cosine of u, so cosine of 45, times sine of v, so sine of 30. Now we're going to find each of these in the unit circle. Sine tells us we look at what? The y. So at 45 degrees, what's our y value? Square root 2 over 2. Cosine tells us we look at what? X. At 30 degrees, what's our x value? Square root 3 over 2. Minus cosine of 45. Cosine tells us we look at the x. We're going to go to 45 degrees. What's our x value at 45 degrees? Square root 2 over 2. Sine of 30. Sine tells us we look at the y. At 30 degrees, what's our y value? 1/2. So now we're going to multiply these together and subtract. So multiply straight across. We get square root 6 over 4 minus square root 2 over 2 over 4. Then we can just subtract these. So we get square root 6 minus square root 2 over 4. Same thing as the answer before. It's not always going to be the same answer, but you are kind of using the same trig function, so sometimes you end up with this answer. But it's not always going to be the same thing. So example 3, we're going to use our sum and difference formulas and write as a single trig function and evaluate. So here, these are written like the right side of our formulas. We have sine of 74 times cosine of 16 plus cosine of 74 times sine of 16. I want to figure out which of my formulas does this one match. Which one goes sine, cosine, then plus? So out of my formulas here, which one goes sine, cosine, plus? The first one. It goes sine, cosine, plus. So we're using sine of u plus v. So the first number is going to be our u. The second one's our v. So this is sine of 74 plus 16. So sine of, what's 74 plus 16? 90. Now we have to evaluate this. 90 is on our unit circle. So sine tells us we look at what on the unit circle? The y value. What's our y value at 90? So sine of 90 would be 1. So this is our answer. We got to write it as a single trig function and evaluate. So you need both parts to your answer. Let's do B. So which of our formulas goes cosine, cosine, plus? Awesome. The last one, cosine of u minus v. It goes cosine, cosine, plus. So cosine of u minus v is what we're going to use. So cosine of 280 minus 40 would be cosine of 240. So this is part of our answer, writing it as a single trig function. Now we want to see what the cosine of 240 is. So I'm going to go back to my unit circle. Cosine tells us we look at what? The x value. So what's our x value at 240? So this would be negative 1/2. So this is our answer. We need to write it as a single trig function and evaluate. All right, next let's do C. So here it's kind of obvious that it's going to be the tangent, one of the two tangents. Which one has tangent with a plus sign up top? The first one, tangent of u plus v. So this is going to be tangent of 190 plus 125. So when we condense this to a single trig function, we have tangent of what? 315. Tangent tells us we look at what on the unit circle? Y over x. So I'm going to go to 315 degrees and find what my y over x is. So when we do our y over x at 315, we get -1. This would be our answer. So example 2 involves a lot of what we've been doing with all of our trig stuff. So it kind of takes it back to chapter 4. We're going to talk about quadrants, all of that. So this involves a lot. So first thing that it gives us is sine of u is 4 over 5. And it tells us that our u is in between 0 and pi over 2. What quadrant would that be? The first quadrant. So we're talking about the first quadrant here. Our triangle would be here. Sine would be what over what? Y over r, that works. Or you could think about it in terms of SOHCAHTOA, but y over r would work perfect. So y over r. Our y value is 4, our r is 5, so we're missing what? X. How do we find x? Pythagorean theorem. So we have 4 squared plus x squared equals 5 squared. So 16 plus x squared equals 25. Subtract 16. X squared equals 9. What does x equal? 3. Do we know, is it a positive 3 or negative 3? Positive. Knowing that it's in the first quadrant, our triangle goes to the right, our x value goes to the right, which means that our x is going to be positive. So that's what this piece tells us. It's going to tell you if you're missing information is positive or negative. It'll help you find that. So this is our important information for triangle U. I'm just going to rewrite it here. We have x equals 3, y equals 4, and r equals 5. Now we're going to do the same thing with another triangle. So it says cosine of v equals -12 over 13. So here we have another triangle. We're going to do the same thing here. Cosine is what over what? X over r. Does that negative go with the x or with the r? It's going to go with the x. Why? Because r is always positive. So we know that that negative is going to go with the x. R is going to be positive 13, but we still have to find the y. Which quadrant are we going to be in here? 2, perfect. In between pi over 2 and pi, it puts us in quadrant 2. Our x is negative, so it goes to the left to -12. R is 13. Let's find y. How would we find y here? Pythagorean theorem, same way we did in the last one. So -12 squared plus y squared equals r squared, 13 squared. So 144 plus y squared equals 169. Subtract 144. Y squared equals 25. What does y equal? 5. Is it going to be a positive 5 or -5? How do we know that it's positive? Yes, since we're in the second quadrant, our y goes up, so that tells us that it's going to be positive. So it'll be positive 5. So in my triangle V, my second triangle said cosine of V, so this is triangle V. I have x equals -12, y equals 5, and r equals 13. And we're not done yet. Going back to the question, it says, find the exact value of sine of u plus v. So I want to write out my formula here. We're using the one of sine of u plus v, so the first one here. So I'm looking at the right side. We have sine of u times cosine of v plus cosine of u times sine of v. Now we're either going to be looking at triangle u or triangle v. First thing says sine of u. Sine tells us we do what? What over what? Y over r. So sine is going to be y over r, but we're talking about triangle u, so we're going to find y over r for triangle u. So our y is 4 over r, which is 5. Next, we have cosine of v, so we're looking at triangle v on the right. Cosine is what over what? X over r, so our x is negative 12 over r, which is 13. Then we have plus cosine of u, so we're going back to the u triangle. Cosine is x over r, so that would be 3 over 5, perfect. And then sine of v, we're going back to the v triangle. Sine is y over r, so 5 over 13. Now we want to multiply these together and add. So multiply straight across. What's 4 times negative 12? Negative 48. 5 times 13? 65. Plus 3 times 5? 15. And 5 times 13? 65. Now we can just add our numerators together and our denominator stays the same. What's negative 48 plus 15? Negative 33. Awesome. So this would be our answer.